Okay, today we're going to look at solving systems with elimination, but just maybe a little bit more complicated. So previously, last week, let's look at an example that we did, an easy one. Like this one here, we added the two equations, solved by elimination. When we added the two equations, we would eliminate the x terms, because 2x plus negative 2x was 0, and so you eliminated one of the variables to solve for the other, and then you could figure out what the other one was by plugging it back in. So the problem comes in, the more tricky ones are ones like this. If you look at this example 1, notice that there are no two variables such that when you add them together they would cancel out. So like negative 5x plus 3x would not be 0, and negative 2y plus 6y would not be 0. So your strategy is a little bit different for this. If you look at the steps, step 1 up here tells you that you need to multiply one or both of the equations by a constant. And a constant is just a number, like 2 or negative 3, so that the coefficients of one of the variables are opposites, or so that they have the same coefficient, but one's positive, one's negative. So if we look at example 1 here, I need to figure out a way so that I could multiply one of these equations by a constant, so that if I added the two equations, one of the variables would cancel. So maybe x would disappear or y would disappear. And for the first one, the strategy is this. You should multiply the first equation by 3, the whole entire equation by 3. Now, be careful when you multiply an equation by a constant, you have to multiply everything in that equation by that constant. So if I distribute that 3, that's going to be, I'm just going to write it in part A here, negative 15x minus 6y equals 18. 3 times 6 is 18. Okay, then if I write the bottom equation underneath of it that we did not change at all, notice that your y terms both have the same coefficient, 6, and one's positive, one's negative. So that now, if I were to add these two equations, my y term would cancel. So that's what I'm going to do. I'm going to rewrite these again. Okay, so if I add these two equations, negative 15x plus 3y is negative 12x. My y terms cancel. Sorry. 18 plus 6 gives me 24. And then if I divide both sides by negative 12, x is negative 2. Alright. Now what I need to do is always solve for the other variable. So I'm going to take what I got for x, I'm going to plug it back into this equation. So 3 times negative 2 plus 6y equals 6. So here we have negative 6 plus 6y equals 6. 6y is equal to 12 if you add 6 to both sides. So y is 2. You can stop the video if I'm going too fast, and you can replay it too. Alright, so there's your solution. There's your ordered pair. That's your solution. If you have time on a test, or if you're doing homework and you have time, I would always check the solution, but just to save time for the video, we're going to keep going. Alright, so let's look at example 2. Here we have another problem where we have to solve the system by elimination, not by substitution anymore. So I'm analyzing my variables, my x terms, my y terms, and I need to ask myself, is there a constant I could multiply one of the equations by so that one of my variables would cancel? If I look at my x term, there's nothing I can multiply this top equation by in terms of my x term, so that when I add it to 7, I get 0. Now I mean, there is a number out there that would work. It's a fraction though, so we don't want to deal with fractions. If I analyze my x term in my second equation, there's nothing I can multiply 7 by so that if I add it to negative 2x, I get 0. So I'm going to start looking at my y terms. My top equation is 15y, my bottom equation is negative 5y. I notice now if I multiply my bottom equation by 3, and I distribute that 3, I'm going to write my top equation, the one that I didn't change up top here. And then my new bottom equation, if I distribute that 3 to the 7x, I'm going to get 21x. If I distribute the 3 to the negative 5y, I'm going to get negative 15y, which was what my strategy was. And then 3 times 17, which is 51. Alright, so I'm going to add these. My y terms are going to cancel, which is exactly what I wanted. Negative 2x plus 21x turns out to be 19x. Y terms are gone. Then negative 32 plus 51 is also 19. So x is 1. To figure out what y is, you can just take that value, plug it back in. Again, either equation will work. There's always one that kind of looks a little bit easier. Alright, so negative 2 times 1 plus 15y is negative 32. So negative 2 plus 15y equals negative 32. If I add 2 to both sides, I get 15y is equal to negative 30. Y is equal to negative 2. Alright, so I have my solution now is 1, negative 2. Again, you could check that by taking that, plugging that back in for x and for y. Let's look at a few more examples. So example 3. Okay, analyze your strategy here. Maybe let's look at the x terms. My top equation is a 12x, my bottom equation is a 3x. Now there is 4. I know I could multiply the bottom equation by 4 so that my bottom equation has 12x, but I really would like one to be positive, one to be negative. So I'm going to multiply my bottom equation not just by 4, but by negative 4. Make sure you distribute that negative 4 to each piece. So I'm going to write my top equation. I didn't change the top equation, but be careful here. Okay, so negative 4 times 3x is negative 12x. Negative 4 times negative 2y is positive 8y. Just be very careful with your signs. Negative 4 times positive 5 is negative 20. Okay. Now this is interesting. Look what happens. When you add these two equations, 12x plus negative 12x is 0, and we wanted the x terms to cancel. That was our strategy. But also, look what happens to the y terms. Negative 8y plus positive 8y actually is 0 as well, and those cancel out as well. So I actually have 0. I have nothing on my left-hand side of the equation. When I add on my right-hand side, I also have 0. Okay, so this is interesting. This is a true statement, though, right? Okay. So if it's a true statement, you get no variables in the end, but you do get a true statement like 4 equals 4, 0 equals 0. The solution is all reals. Or you could say infinitely many solutions. All right, one more. All right, let's analyze this. 2 equations, 2 unknowns. I probably have a couple strategies here for this one. I could multiply in the top equation. I could multiply the top equation by negative 3, and that would get my x terms to cancel. Another option I have is to multiply my top equation by negative 7, and that would get my y terms to cancel. So there is sometimes more than one option, and there's more than one way, more than one correct way. I'm just going to stick with this one. So I'm going to make a note to myself with this here to make sure I distribute. Alright, so when I distribute, I get negative 14x minus 7y equals negative 28. Making sure that I'm careful distributing that negative sign each time. My bottom equation I didn't change at all. So I'm just going to write that. All right, so negative 14x plus 6x is negative 8x. My y terms cancel. Negative 7y plus positive 7y is 0. And negative 28 plus 12 is negative 16, which means real quick you can figure out x is 2. Alright, so you guys are pros by now, I'm sure. You just take this, plug it back in. This one looks a little easier. So 2 times 2 plus y is equal to 4. 4 plus y is equal to 4. That actually means that y is 0. Alright, so your solution to the system is 2, 0. Okay, we'll do more of these tomorrow.